Okay, let's be honest for a second. Has anyone else ever looked at a math equation and just felt like they were staring at hieroglyphics? It's like, where's the Rosetta Stone for understanding this stuff?
It can definitely feel that way sometimes.
Right. Well, today we're ditching the ancient languages and diving headfirst into the fascinating world of equations.
Sounds like fun.
And trust me, this isn't just about memorizing some dusty old acronym.
You're right. It's not just about memorization. It's about uncovering this incredible inherent elegance in how numbers actually interact. It's like math has its own grammar, and once you understand the rules, you can unlock a whole new level of understanding.
And that's where our deep dive source, the Math Map curriculum, comes in. It introduces this concept called GIMA as a way to understand the order of operations. GIMA sounds catchy, right?
It does.
But is it just another acronym like PEMDAS? Or is there something more to it?
Well, Gimma is definitely more than just a fancy word. Think of it this way. Imagine you're trying to follow a recipe, right? You wouldn't just throw ingredients together in any random order, would you? There's a specific sequence that makes sure the dish turns out just right. Well, Gimma provides that same kind of order for math.
Okay, so it's like GIMA is the recipe for successful equations.
Exactly.
I can get behind that.
And what's so fascinating is how reveals these deeper truths about the relationships between numbers. It's not arbitrary. There's a logic and elegance to it.
Okay, you've got me intrigued. Walk me through this thing.
Right.
What's the first ingredient in our recipe for mathematical success?
First up, we have groups, which refers to any part of the equation that's grouped together. Parentheses, brackets, even the numerator and denominator of a fraction. You always deal with whatever's inside these groups first.
So it's like those little asides you sometimes find in sentences, those parentheticals.
Yes.
You got to understand what's in those before you can grasp the full meaning of the sentence.
Precisely. Once you've taken care of those groups, you move on to indices. Now, this might sound a bit intimidating, but it simply refers to things like exponents, roots, and logarithms.
Indices. I have to say, it sounds a lot cooler than just saying exponents.
It does, doesn't it?
It's like we're leveling up our mathematical vocabulary already. But in simpler terms, what are indices really doing?
Think of indices as a way to condense repeated multiplication. Like, instead of writing 2 by 2 by 2, we can just write 2 cubed, which is, a more elegant way of expressing the same idea.
It's like mathematical shorthand.
Yes.
Okay. So we've dealt with the groups, we've tackled these mighty indices. What comes next in our recipe?
Now we get to the heavy lifters, multiplication and division. And here's a key point. Even though they're grouped together in Gima, you perform these operations from left to right.
Just like reading a sentence. You wouldn't jump around the words. You follow the order they appear. Okay, that makes sense. So what's the final step in our journey?
The last step is addition and subtraction. And just like with multiplication and division, you work these from left to right.
So we've got all our ingredients laid out. We've got our order of operations. What's next? Do we get to taste this mathematical feast?
We do. Let's take an example. Okay, imagine you're faced with this equation. 3 plus 4 times, in parenthesis, 5 minus 2, close parenthesis, squared. It looks kind of intimidating at first glance, right?
Yeah, a little bit.
But with Gima, it's a piece of cake.
Okay, I'm ready to be amazed. Talk me through it.
All right. First, we've got to tackle the groups. So that's the 5, 2, which simplifies to 3.
Okay.
So now our equation is 3 plus 4 times 3 squared. See, already looks much cleaner, right?
Yeah, it's like we decluttered the equation. Okay, so what's next?
Indices, we have that 3 squared, which of course is 9.
Right.
So now we're left with 3 plus 4 times 9.
All right, so no more parentheses, no more exponents. It's starting to feel a lot more manageable.
Exactly. Now we come to multiplication, 4 times 9, which gives us 36. So our equation's been simplified down to 3 plus 36.
And finally, the grand finale. Addition. 3 plus 36 equals 39. We did it.
We conquered the equation.
We did, but I mean, it wasn't about just brute force, right? It was about understanding the order, the logic behind each step.
Right, exactly.
Like we talked about earlier, math having its own grammar. We're not just crunching numbers, we're uncovering a deeper structure.
Yes.
That's pretty cool.
It is cool. And this source material, the math map, it doesn't stop there. It goes on to introduce a MIG, which is essentially in reverse.
Wait, so if it's about building the equation up, AMIG's about taking it apart.
Yeah, exactly. Remember how we were talking about equations being like stories?
Right.
Well, AMIG is like the detective who comes in to solve the mystery.
Ooh, I'm intrigued. So tell me, how does this mathematical detective work?
So let's say you're given the equation. 2x plus 5 equals 11, and you need to solve for x. Aiming helps you isolate the X by systematically undoing the operations.
So instead of following Gamma from left to right, we reverse the order with AMIG.
You got it. Okay.
First, we tackle the addition and subtraction. In this case, we subtract 5 from both sides of the equation,
Right.
which leaves us with 2x equals 6.
So it's like we're peeling back the layers to get to the heart of the matter. What's next?
Then comes multiplication and division. We divide both sides of the equation by 2, which gives us x equals 3. We've solved for x. Boom! And just like that, the case is closed. But, I mean, it's more than just getting the answer, isn't it?
Absolutely.
That's,
Just like with AMIG helps us to see the why behind each step. We're not just memorizing a process, but we're understanding the logical relationships that make these equations work.
and that's where the real aha moment happens, right?
Yeah.
When you see those connections and it all clicks into place.
Exactly. It's about more than just finding X. It's about uncovering that inherent order, that elegance that's built into the fabric of math itself.
It's like we're not just solving for x,
Mm-hmm.
but like uncovering these hidden pathways, and each step is revealing this new layer of understanding.
Yeah, that's a great way to put it. And this whole idea of uncovering hidden pathways, it reminds me of something else fascinating from the math map. It talks about how this order we see in math, this elegance of Gima and Amig, it it isn't just some human invention. It points to something much, much deeper.
Okay, now you've got my attention. What could be deeper than solving for x?
Well, the source material connects this inherent order in math to God's design. It even quotes 1 Corinthians 14.33, "For God is not a God of confusion, but of peace." Just like, language has a proper order for clear communication, the universe itself operates under principles of order.
So you're saying that math isn't just this abstract system that we've created, but like a reflection of something more fundamental, something like woven into the fabric of creation.
Exactly. When we understand an AMIG, we're not just memorizing rules for solving equations, we're catching a glimpse of the blueprint of creation.
Wow, that's a pretty awe-inspiring thought. To think that something as seemingly simple as the order of operations could offer a window into the mind of the creator.
It really is. And it reminds me of that quote we touched on earlier, mathematics is the art of explanation. When we use math to explain the world around us, we're tapping into that deeper order, that elegance that reflects the creator's hand.
That makes me think about how we often talk about appreciating God's creation in nature, right? Like the intricate patterns in a flower or the vastness of the stars. But this is like appreciating the elegance of his design in the language of math itself.
Precisely. And just like exploring nature can fill us with wonder, so too can exploring the world of mathematics. It's about opening our minds to the beauty and order that surround us, both in the seen and unseen realms.
This deep dive has been incredible. We've gone from feeling lost in a sea of numbers to seeing equations as these elegant expressions of truth reflecting this deeper order present in the universe.
It's amazing what happens when we start asking why, isn't it? It's not just about finding the answer, but understanding the journey, the logic, the beauty behind it all.
Absolutely. We've unpacked Gima and Amig, we've cracked the code of equations, and we've even glimpsed the elegance of God's design in the process.
And the best part is, this is just the tip of the iceberg. There's a whole universe of mathematical wonders out there just waiting to be explored.
So to our listeners, we leave you with this final thought to ponder, inspired by the Math Map. If math can help us understand the order in God's creation, what other secrets might it unlock? Until next time, keep exploring, keep questioning, and keep diving deep.